Hi there, this is Jacob Nash again, and this is part 2 of solving for problem number 5 on 2.1.1. Now, I may have added this with the other video. I can't remember if I did that, so it might seem weird that this just happened, but I don't know if I'm going to leave it separate or not, but we'll see what happens. So, as I was saying in the last part that there was, we're doing the table now, and it says YIAI and then YIAI. That we need to fill in the values we have for that. So YI just means the centroid coordinate, the Y centroid coordinate. And we need to fill that in for shape 1, 2, and 3. And I'm sorry, I only labeled 1 up here. We'll say that the semicircle up here is 2, and then the rectangle is 3 right here. So for the Y centroid coordinate, and like I said, this is backwards for some reason. Typically, the X would be on the top, so don't get tricked by that. The Y coordinate for shape 1 of the centroid, we said was 1 inch. For shape 2, the Y coordinate was originally 0.27, but remember we changed that to 1.73 because we had to do it relative to the axis. Then for shape 3, that is we said it was, we didn't have to change that one, it was just 0.25. And you might wonder why. Oh, sorry about that. That's because this is the distance. It already is relative. This distance starts on the axis, so we didn't have to change it. Now, AI means the areas for the shapes. That's why we had to calculate the areas earlier. So we remember it was 4 inches squared for shape 1. For shape 2, it was, remember, negative 0.61 inches squared. And then also negative 0.375 inches squared for shape 3. YAI. Now, what's that? You have to multiply these distances. Let me hold this up closer so you can see what I have. So, am I doing this? Oh, this thing's a little bit backwards, I think. There we go. Now hopefully you can see what I have. I'm putting it back down now. So we have to multiply those distances. And when we do that, these are powers of 1, technically, since there's nothing there. So it has to be cubed. Yeah, this thing's frozen. Sorry about that, if you can see. See, I can move my mouse on this computer, but remember, I'm doing something strange. So I'll write down what it is, but you might not see me do it. So 1 inch times 4 inches squared, that is 4 inches cubed. Yeah, still frozen. Sorry about that. And then 1.73 inches times 0.61 or negative 0.61 inches squared is negative 1.06 inches cubed. Thing's still frozen. And then 0.25 inches times negative 0.375 inches is 0.09 inches cubed. I don't know. Okay, so I can see on my computer this actually has the camera on. I can see what I just wrote, but for some reason I can't see what I wrote on this computer. It's just frozen for some reason. Let's see. It looks like it's starting to move. There you go. There we go. It fixed. So now we see total. There's something total right here. We need to add up these areas, and we need to add up these multiplied areas and the y-coordinates. We need to do sum. The sum of symbol is uppercase sigma. That's a Greek letter. Once again, with the Greek letters. That's uppercase sigma. We've used the lowercase sigma before, but now we're using uppercase sigma. So that means sum. And if you took Intro to Engineering Design, you remember that. So we write sum. So the sum of these is 3.015 inches squared. And then the sum of these turns out to be 2.85 inches cubed. There you go. We've done the top part of that. The bottom table is the x coordinates. That's what we first need to do. So the x centroid coordinate for shape 1 was still 1 inch. That's why it is a square. And then for shape 2, the x coordinate was also 1 inch. But remember, it was at first 0.625, but we had to change that because of the reference angle. We already said that. And then it was also 1 inch for the shape 3 because we changed that from 0.375 to 1 inch for the same reason. Now, luckily, these areas are the same for both parts of the table. So you just write these things down here. So I'm just going to write same. Your teacher probably wants you to write it, but I'm just going to write same for time's sake. And then the area is, the total is, again, the same. It's still going to be 3.07 or 15, sorry. But it is different when you multiply it this time. So all you have to do is multiply it by 1. So you see, 1, all these are 1, so that means that all of these are going to turn out to be the same as these. So that means it's the same as this, because we're multiplying it by 1. So that means it's going to be 4 inches cubed. Well, the only difference is that it's cubed instead of squared. And then 0.61 inches cubed, and then 0.375 inches cubed, negative though. So then the sum is still going to be 3.015 inches cubed though. That's the only difference. So there we go. We got the table filled out. Let me try to hold this up so you can see it. Oh, well, last time when I put the thing down, that's when it froze. So I'm going to put this down slow so it doesn't overwhelm it. There. So we've done step 4, the table. Now we need to, well, we already did the sum. That's part of number 5. Now we need to use the equations we have. So the equations are y equals sum of yi ai divided by sum of ai. And then we have x equals sum of xi ai divided by sum of ai. So we just plug in the numbers we already have. There's not much math that you're doing. So the numbers, so the sum of xi ai, that's this. This is what we already did. Is it frozen again? Oh. Hang on, let's see if it gets better. Now this thing's taking long. If you notice that this video is long, it's not actually going to take you this long. That's just because I'm going in depth about it. So it looks like it's starting to kind of fix itself. But anyways, This is XIAI. Oh, this I'm just telling you, I'm never going to do this again because of how delayed this is. Let's see, maybe that will work. I don't know. Well, the sum of XI AI is what is the sum that we got down here. You can't see where I'm pointing. Well, actually, I'll just do this. This. That's what I've been trying to do. So we're going to put this right here. Or sorry, this is for the X. This right here. So I'm writing 2.85 inches squared. Or cubed, cubed. And then, oh, fix itself. So then sum of AI is this. That is 3.015 inches cubed, or squared, sorry. And then for this, it is 3.015 inches cubed. And then remember, it was the same for xi. So there you go. We have the equations, now we solve. And when you solve those, for the x, which is this, you get just 1 inch, because that's the same thing on the numerator and denominator. Now, because that's 3 cubed divided by squared, that makes it just to the first power, so you don't have to write anything there. And then for the x coordinate, or sorry, y, you get 0.95 approximately inches. So there you go. We have the coordinates. All that work, and we finally got the coordinates. Now, last thing to do is just to write the centroid. Draw it on here. And then line over. X is 1 inch. Y is 0.95 inches. And there you go. That is how you find the centroid of a complex shape. That took a long time, but after you've done it a couple times, it should be quick. And that was for the subtractive method. For the additive, you would just do the same thing, except for the areas would be positive. And that is it. We did all that work, and it paid off. Thank you for watching this video, and that'll be it.